Hey, Mr. Dmitrowicz, in that last video, we were learning about the number of atoms, protons, neutrons, electrons, and we got introduced to the periodic table. But now what we want to do is we want to kind of go deeper with the periodic table.
Yeah, the periodic table is the all-star here, and it tells us a whole bunch of stuff. So I think we have a video here that kind of is going to talk a little more about that.
Let's go.
So, Mr. Bergman, what are you standing in front of right now?
So this is the periodic table. We've already talked a little bit about the periodic table. It's like the thing. It's like the bomb. It's the biggest tool in all of chemistry. But it's organized in some interesting ways. There's actually two main categories of elements. Okay, I'm talking about the first set over here. You might see there's kind of a darkened line right here. In this darkened line stair step, above and to the right, what we have, what we call non-metals. And as a side note, there's one weird element. The weird element that is that. This is hydrogen, which is a non-metal too. He fits in this category. He's over here. Later we'll learn why that is. Now, if you think about it, if these are non-metals, I said there were two categories. The other main category would be the metals. The metals is like almost all of the atoms. Ooh, all of these guys all the way here. Again, not including hydrogen. Those are the metals. Copper, zinc, nickel, gold, mercury. Those are the metals. So if we talk about metals, I brought three metals with me to the table, so to speak. I have got a piece of lead, a piece of copper, and then some wire that's aluminum wire. Now, one thing that you'll notice about the metals, lead, it's a little bit oxidized on the outside, but they're shiny. So one thing you'll find with all metals is that they're shiny. The other thing that you'll find about metals is that they're all bendable. We have a fancy word for bendability, and we call that malleable. Malleable. So, and also, you probably know this, your mom taught you this, if I were to go stick this in an electrical socket, it would be a bad day for me. So they also conduct electricity.
And heat.
And heat as well, yeah. That's why we make our pans out of aluminum.
How about that wire? That's another cool thing about metals. They can be pulled into wire. We call that.
So that's called ductility.
Yep.
So you can take copper and make it into a wire. You can make a lead wire, etc., etc. So now if you think about that, that's a metal. The non-metals are like the opposite of metals. So if we define things as not malleable, not ductile, not conducting, that's what we talk about. In fact, I have an example of a non-metal. So I happen to brought a non-metal now. This non-metal is sulfur. Now if you zoom in on this, what you'll see, of course, is it's kind of a yellow powdery stuff, not shiny. You couldn't make that into a wire. It's like it's this little powdery stuff, right? And so that is a non-metal. Another example you might be well aware of is just a piece of charcoal.
Yeah, it's like carbon.
Yeah, that's just carbon, element number 6. And it's, you know that's not shiny, you can bend it, it kind of breaks, it's brittle, things like that. And then last thing I want to say is there's also sort of a weird category of elements that are in between metals and non-metals. And the example, these are the ones that jump along the stair step. The most important one, or the most sort of famous one, is silicon. Silicon is in the chips of computers, and they call it a semi-metal. Makes sense? Semi, kind of like a metal and kind of like a non-metal. So it kind of conducts electricity, can kind of be drawn into wire.
Semiconductor, that's the term.
It's a semiconductor, the whole semiconductor industry for computer chips. Silicon is that thing. And some of these other ones will also do similar properties. Aluminum's kind of weird, it is just a metal. But the ones that, border the stair step are called the semi-metals, sometimes called the metalloids, same thing. So another thing you can learn about the periodic table is that the colors on this table tell you the state of matter, solid, liquid, and gas. If they're black, they are at room temperature, they're going to be a solid. If they're red, nitrogen, oxygen, you can know that oxygen is a gas, and if they're blue, then they are liquids. You might notice there's not a lot of blue. We've got bromine and we've got mercury. In fact, let's take a look at mercury.
This is mercury. Very kind of scary thing, but if you can notice here, this is a liquid, and if this were to break, we'd probably run, because as a liquid, it's not so bad, but in the heat here in Houston, it turns to a gas, and that gas is kind of bad for you. You guys may remember Alice in Wonderland, the Mad Hatters. They used to use mercury in the hats, and that's why they kind of went nuts.
So, Mr. Dmitrowicz, at the beginning of the video, you said that the periodic table was the star, but it's really leading us to something else. What is it leading us to?
Bonding. We really care about, and this is the fun part of chemistry. Let's be honest, Mr. Bergman, right? This is where we get to take atoms and put them together, and you get new stuff, and it's cool and it's fun, and sometimes you get fire, and who doesn't enjoy fire, right?
Yeah, we got to set a few things on fire. That's the idea, folks. Is reactions happen when there's changes in bonds. That was Dalton's law from a long time ago, right? They rearrange themselves, and we have to kind of know what types of elements we have, and we just did that. So as atoms get together in bonding, we're headed towards sort of an idea of bonding and how they get together. That's the cool part of chemistry, like you said, Mr. Dmitrowicz. So folks, I think that's all we've got for you in this segment. So we will see you guys in class.
See you later.